Okay, so in previous lessons we introduced what the atomic hotel was. So in the atomic hotel, and this was a result of quantum mechanics, so it's kind of hard to explain why it works the way it does, but according to quantum mechanics, electrons can only live in specified energy levels inside the atom. So this is the atomic hotel, and on the first floor you had room for like 2 electrons, and then on the second floor you had 2 rooms, and one room contained 2 electrons, and then over here you had 6 electrons. So hopefully you remember this. And then when you go up to the third floor, it turned out that there were 3 rooms, and then one room could hold 2, one could hold 6, and then one could hold 10, and so forth. So that electrons lived on different floors of the atom. Okay, then when we talked about stars, we talked about nuclear properties. And inside the basement of the atomic hotel is the nuclear hotel. So now we're talking about the nucleus of the atom. And according to quantum mechanics, the nucleus of an atom can have different energy levels. But this time it's going to be where the protons and the neutrons live. And so, for example, you could have 2 protons and you could have 2 neutrons on the first floor of the nuclear hotel. And then when you went to the second floor, it could hold a different number of protons and neutrons. Now what we're going to do is, using the rules of quantum mechanics, we're going to look inside a proton or a neutron. So remember that these were called nucleons. A proton is a nucleon, a neutron is a nucleon. So let's say that we're looking inside of a typical proton to see what's inside of there. And so we know that inside of a proton is going to be an up, up, and a down quark, for example. So where do those quarks live? So there's going to be a nucleon hotel, and then on the ground floor of this thing are going to be 3 quarks. So that would be your up quark, and then your down quark. So I'll just use the letter Q for quarks, so that on the ground floor of this apartment building, you always are going to have 3 quarks inside of a proton or 3 quarks inside of a neutron. However, you can have other particles inside of this nucleon hotel. All right, what are those particles? So what I want you to do is watch this video. So you may recall Physics Girl. So she was the one that explained the supernova explosion. So now she's going to explain what's inside of a proton and a neutron. Okay, so watch that video, Quarks Explained in 4 minutes by Physics Girl on YouTube. Okay, did you watch that? Wow. So this, now you can see that things are getting really, really weird in there. Because not only can you have your 3 quarks, which you always have to have in there, but you can have other particles that are appearing and then disappearing, because where are they coming from? This energy vacuum. So you can have other particles that are appearing on the other energy levels like this. And so it's not just, so you can have quarks and antiquarks that are appearing and then disappearing for short periods of time on these other energy floors. But then you also have these other particles. The particles that are gluing the quarks together are going to be called gluons. And so we'll talk more about that in a future segment. And then also, do you remember that there were those super symmetric particles that allowed leptons to be able to communicate with the quarks? So, and then there was also things like bosons. So do you remember that, for example, when an electron would jump up and down, it emitted a photon of light? A photon is a boson. It's a fundamental particle. So as these quarks jump up and down in their energy levels, they are also going to be emitting different kinds of radiation. So this was mentioned on the video, and so you notice you do not need to know this for the exam, but it's kind of interesting that where does the mass of a proton come from? So 9% of the mass of a proton comes from the 3 quarks that when you put them together, it makes a proton. But something has to be holding those quarks together. And so that's going to be those gluons. So the gluons interacting with the quarks, and then the gluons interacting with themselves makes up another 23% of the mass of a proton. Now the quarks are moving around. So if a quark has mass and it's moving with the velocity v, it's got kinetic energy, 1/2 mv squared. And so that kinetic energy can also be turned into mass, okay, because energy is going to be equal to mc squared, so that if the quarks have kinetic energy, then they have mass associated with that energy. And that's 32% of the mass of a proton. And then the gluons, the things that are gluing the quarks together, are also moving around inside there. So the gluons have kinetic energy. So all of these different kinds of particles contribute to the overall mass of the proton. All right, let's take a break. When we come back, we will talk about what dark matter is.